Hello friends and followers. Well, I never thought that I would need a spectrum analyzer. I bought this spectrum analyzer because I thought it was cool to have one. I've always wanted one, and they're pretty useful for tuning up duplexers on repeaters and all that stuff, but never could afford one of these. Probably, I don't know, 10, 20,000 bucks back in the 70s or whenever. Anyway, I picked up this module on eBay and it seems to work. So I'm using the spectrum analyzer now to analyze the burst output on the HRO 500. So I'm probing what's going into the synthesizer comparator module now. This module is the comparator, meaning that it will build up an IF signal. And what the book says is this IF signal about here should be about 4 volts peak to peak, and that compares with the crystal back here into these two creaky diodes. So that's the story. There's a mixer right here, which I think in my case was burned out. I put a silicon transistor in there. You can see it sitting right there, out of the Chinese communist transistor stock I have from Bojack. And it seems like it's mixing. I may not get the right gain out of it, but I ordered a replacement germanium transistor from eBay for that. But anyway, I struggle along. So how do we verify if the spectrum generator is generating correct burst output? Well, in the book they have some pretty fancy diagrams. And here's the spectrum analyzer. So the first thing you notice is this has a band switch on it, which pertains to this band switch. So in lockstep, when you change bands, this little wheel has to move and put in RC capacitors to select the correct segment of the burst that you're interested in. So if we go fully counterclockwise, that's the highest band. And you can see that that doesn't look very impressive. And as I rotate from the highest clockwise setting and watch the spectrum analyzer, you'll see it'll perk up there. That itself doesn't look like it's too useful. You need a really strong singular signal for it to lock onto, and that doesn't have one. So if I keep on going a little bit here, it kind of punks out, and then there's something useful. So I'm thinking that's what we want. And I'm hoping it's for this band here, but how can I be sure? So now I'm trying to figure out how I can measure the frequency of that peak. But that peak is good looking. And when you now rotate the synthesizer tune control, you'll notice these will descend and another one ascends. So that's the behavior you want on how to run this radio. And so these peaks here will mix with the high frequency oscillator in this mixer here, and then you'll get a 4.75 IF out of this thing. So that's how it should work. In fact, I am using a scope probe on that. So I have 2 scopes now to use, and I probably could move the scope down to here and take a look at what's going into the comparator down here. That's actually a good spot for that, is right about here on the diode. And then for this scope, maybe we can use this, or for this analyzer, spectrum analyzer, maybe we can use this probe here. Let's see if it works. All right, let's unplug this. See if it gets the same results or not. I have no results there because it's not plugged in. Okay, spectrum is here. All right, so that gives me something with more amplitude than I want. I crank down the amplitude here, sure. However, that looks different, doesn't it? I wonder why. I don't know this generator that well yet. Really how to use it much at all. I'm just kind of going through and looking at it pictorially. So this seems to be the vertical here. So I got a little rise there out of it. Let's see if we can get that more clearly represented. And as you can see, I'm just tweaking away here. Anyway, I'm not sure why this is so bad through my probe. This will do like a log on it, so linear 2 dB, 10 dB, okay. At any rate, if I spin the synthesizer now, it'll do the same old game here. You'll see it ascending. I liked the display before where I saw a definite peak. I'm not sure why I'm getting 2 peaks there. Anyway, so that's kind of where this thing would want to lock. So with the other scope then, you'd want to see a nice strong signal. And I don't really get much out of it, so we're looking at the input now to the comparator. Let's look at the output of one of these cans here, right about there. That should give us some IF. There we go. So the whole thing here is then the HF oscillator has to be sort of stable around where this is expecting the RF to be. And so we'd want to determine which of these peaks we're looking at. And I think my HF oscillator is not aligned with the synthesizer, with the burst. That's probably part of the problem here. And surely if I spin through here, I should see this thing picking up something, but it's not picking up a darn thing, so. Why is that? If this is loaded down a lot, let's unload this. That's gonna affect me. So, can I see anything? No. Let's go to a greater scale. And keep looking. So we're here on the IF. So yeah, I'm not going to see anything unless the HF oscillator is in agreement. So we know that this is at least scanning and stepping. And of course the switch is also bonkers too, so let's give it a little whirl here, try and get it centered. I have a new shaft coming for this switch, so it'll probably make it more reliable. At any rate, getting nothing out of here. Oh, I know why. It's not connected. That's a problem. That would do it. Okay, finally. Stupidity on my part. Sorry about that. Okay, so there's a signal. 10 millivolts. What about 0.1 volt? So it's not much of a signal, but let's put this guy back on here. Does that affect my, oh yeah, that affects my, loading that down affects my IF. As you can see, when I load that down, I lose IF signal. So much for the spectrum analyzer. Okay, so that's coming in through the IF. It's supposed to be roughly, I think, 4 volts at the comparator. So right about here, you think you get 4 volts, right? Well, it's got some power there. So I'm not sure I like that, but it's probably mixing with the other signal. There's two 4.75s mixing here. All right, so what's the amplitude on this thing here? 20 microvolt, 50.1. So the amplitude is real low. and that's not going to cause the comparator to work. So anyway, I've tried tweaking these for better amplitude. I think they're tweaked. So that means the mixer is not up to snuff, or this is giving too low of output, or the HFO is giving too low of output. One or the other isn't really up to snuff. So let's vary the synthesizer tuning, which will turn this, which will allow us to find a peak, and it also turns the HF oscillator down there, which will change the frequency of the HF oscillator. So if the HF oscillator is off in frequency, that's really going to cause us some trouble. So I think, yeah, nothing changing here. So I think what we have to do, and that's miserable. So let's go upstream here and see what we can find. So out of this can here, we should see some IF coming through. Okay, there's some IF coming through right there. Let's tweak the synthesizer again and watch that change. Not much of a change at all. So that's kind of miserable. Looks like there are two waves in there, doesn't it? It's locking on one or the other. Should there be two waves in there? Perhaps. Okay. So it does change it a bit, but what I really care about is the general amplitude here, and I shouldn't be getting much at all through there unless this is just residual crap noise. So what if we go up here? See what's happening here. Okay, that's a lower version because it's upstream. Pretty much the same thing. So let's go back here to the second can here. So that begs the question then, what's it look like going into these things? This is from the burst generator. We've put the spectrum analyzer on this. Where's my camera? There we go. Let's check this real quick. This is the burst generator here. There's the burst generator bursting. So this is the time domain. This scope can't do any. Okay, so there's the wave. That looks pretty funky. So let's try and see how much amplitude it has. Okay, 0.2 volts. 0.2, 0.4, that's about a volt coming in. It's exactly a volt coming in. There's a volt coming in there. So we got a volt coming in. Does that change when it seems like the higher frequency here changed the output. So if I kind of crank this thing up a bit, amplitude goes up. Well, that's nice. What if I crank it down? Okay, that's fine. I was kind of checking it around 15. There it is, 15. 15 right there. All right, so what does that tell us? If one of these is 4.75 megahertz, I think below or above HF oscillator, that should give us 4.75 to trickle through these cans. Okay, the HF oscillator is being scanned as per usual. And that looks dead, doesn't it? So that's no fun. Why is it dead? So HF oscillator's dead. That's not going to help, is it? it's dead because the band switch is whacked. Let's see. Yep, damn it all. So, you have to make sure both inputs are working, and as you can tell, this band switch is screwed up, so that's got to get fixed. But right now, I want to get the radio just to work. So, okay, make sure you have input. There's the HF oscillator, and at 0.2 volts, we're doing what? Vertical position is where? Here. So that's about 0.2 volts. 0.2 volts, roughly, a little more than that, but not much. So, not much excitement with that. 0.1 volt scale here, we have 0.1, 0.2, yeah, 0.25 volts. So that HF oscillator seems low to me. So then the mixer is mixing these signals indiscriminately. It doesn't really care. So the mixer is going to be putting out both of these mixed into this can here. So that, let's see, where is that guy? There's the transistor there. There's the capacitor off the transistor into the can. So if we connect into here, this is out of the mixer. It doesn't look very impressive, does it? Well, no, it's mixing away. What do we got here, roughly? So this is going to be, well, it's low. Not much of a signal, is it? 0.1 volts. Probably about 0.1 volts peak to peak. Nothing great. Okay, but the characteristics of it, and I think if I vary this, it's not going to really care. At the mixer point, yeah, we don't really have any filtering. So the amplitude of the burst is going to change, and that's going to change this. Now what matters is these cans act as 4.75 filters. So when I go to the next can, or even the output of this one, which comes out of here and goes through a capacitor, let's just look right there. That should be a bit agreeable to 4.75, and as you can see, it's a bit stunted here. So that means the HF oscillator probably is on the wrong frequency. So if I spin this through, it'll change a little bit, but nothing terribly impressive. I really want to see a huge amplitude at 4.75 megahertz on the IFs. And I can't say that's a huge amplitude, so the mixer's bad, or the signals into the mixer aren't strong enough. Second can here, yeah, so it's amplified. It should be the same song and dance pretty much. Change the synthesizer tuning, and yeah, that really filters it, doesn't it? Okay, let's look at the third can here, output. What's this going to? I don't know. Third can output is here. There's the third can. There, where is the damn output here? Transistor into the can. Okay, it's right here. So that can is center tapped, I think, into the diodes. At any rate, that's a sad story, isn't it? Turn the synthesizer on that one. So that's not very impressive, is it? That's never gonna lock. Okay, what about going into this can from the transistor here, this little, okay, this might be the input here. Maybe I'm on the wrong pin. This capacitor comes off the transistor and goes into the can. Maybe that's where to go, right there. Not very impressive. So we're losing a lot somewhere here, huh? So that is pitiful. .1 volt, we have nothing. And if I go back here, that at least has some signal. .1. Yeah, so that's about 0.2 volts peak to peak. So that means this transistor is crapped out, or this can is not tuned right. I know the output of the can goes pretty much to here from last night experimenting. Yeah, that's nothing. So what if we is the can even tuned right? I thought I tuned it right. If we go here, okay, going into the can then, where are we reasonable? We got a signal going in. Definitely a signal of some sort, right? Okay, signal going in. Signal coming out is what? Going to here, I think. Very low. Let's get in there and take a better look at the can. And the wiring. I'm trying to figure out where it goes. Okay, yeah, so the can has this purple wire, which is coming off the back of it. So I think that's a reasonable spot. So either we got a bad transistor or we got a funky monkey can here. So anyway, yeah, there we go. And where's our tweaker tool here? I don't think this will help because I've been through this a few times now. Yeah, see, that's pretty much peaked out, so. Doesn't do crap. What if we pull the transistor? Does it care about that? Would it go down to nothing? You think it would. If we pull this out, it doesn't change a bit. So this really is not doing a damn thing. And these are all PNPs pretty much. So I had a transistor hanging around here that I was playing with last night. I've been shoving in silicon transistors because that's all I have. And I think this is a PNP here. Let's see. I know that this 556 is a PNP. Is this a 556 or not? Yeah, this sucker's a 556. So this might, since I have an amplifying or mixing down here, maybe this will fire this thing up. Let's see if I can get it in there. turn off the power. And that one is at least approachable. Put this thing in here. Did it go in? No. It didn't go in. I probably gotta put the phone down. Gotta put the phone down. Give me a minute. Okay, so I'm gonna put in this transistor now, and we'll see if it helps the third IF stage on the comparator. If not, of course, I should get some original ones and put them in if I could find them. Boy, these are nasty to get in. There, it's in. It's in. So that transistor is in there now. Did it make the change, or is it going to do nothing? I don't think it'll be worse than it was. Power on. Doesn't look like it did a thing. Let's take a look here. Nope. We're still pretty low in signal. Nothing changing. All right, well, that's where I'm at. I gotta figure out, is something blown? Are levels right or wrong? It's a mystery. I think I've given people the theory of this thing, at least how it should work. But the practicality of measuring voltages and making it work are two different things. At least now we know what the stages do. Spectrum generator. This switch goes with the band switch. This tunes which one of those peaks can be seen and rise up and down on the spectrum analyzer. This capacitor way in here, well, you can see it down in there, right there. That is actually ganged, that capacitor is ganged with this one. And when you turn this knob, they both turn. You can see that wheel is turning there. They're both turning. And so this one's doing the HF oscillator, this one's doing the actual peaks. Those gotta be pretty much in agreement, or you're not gonna sync. So that's something else I need to look at with the frequency chart, and I'll do that. In fact, if I could figure out how to get frequency out of this thing and what those spikes are, that would be an agreeable way to do that. And then you want to go for the maximum 4.75 through the IF can. So maybe the reason why I just am not getting anything is the spikes out of this thing and the HF oscillator are out of alignment. So I'd want to loosen this thing up and change this little capacitor. It does seem reasonable, and if I take this thing over to one side, all the way over to like meshed, this one is now meshed, and that big one is meshed perfectly. So it seems like, if you look at the one inside there meshing, you can see it moving up and down there. Now it's meshed. This one's now meshed too, and they pretty much do that in exact agreement. So I think they're lined up. Anyway, any comments? Leave them. I could use them. Take care. Have a nice day. National Company, HRO 500.